Hello. It seems that there's this funny thing going around lately that are keeping people indoors, and I'm trying to find something to do to keep myself from losing whatever sanity I have left. So I've got ideas for a number of projects, and I am putting this out in order to gauge people's interests to see which one I should be working on first. The first project idea involves combining the results of these two videos here. This one was based on a project where I 3D printed a gnomon that would cast a shadow on a piece of paper, and I would mark the end of the shadow that the gnomon cast, and then from there to be able to determine what the sun's path was. The second project that I had done involved measuring the sun's light intensity using a photoresistor. And if you don't know what a photoresistor is, it's just a thing that will change its electrical resistance based on the amount of light that hits it. And so I had used one of these things to point towards the sun, and I measured the lowest resistance of the sun at that particular time of the day. I did that on several days, and this video here was the result of that. But in both of these cases, I was going outside at regular intervals, taking these readings, and I tried to find a way to automate that process. I bought an Arduino Uno kit, thinking that I could use the Arduino to drive the motors to be able to track and to move that photoresistor around to find the best location in the sky and to send that coordinate along with the reading from the photoresistor to a computer and have the computer log all of that for later analysis. And one of the things that I needed to be able to do was to ensure that the stepper motor and or the servo motor that I was trying to use was adequate enough and repeatable enough that when I told it to move to a particular location that it did do that. So one of the first things that I did was to develop a little program that would get the Arduino to move the servo motor, let's say maybe to here at position 1, and then move it ahead to position 2, then ahead to position 3, and then I wanted to see if asking it to move back to position 2 would make it move to position 2. And I noticed that the servo motor would go ahead one step. It would not necessarily go back one step. So then I moved to the stepper motor. And the stepper motor is definitely far more controllable. So I think going forward, I'm going to have to use the stepper motors instead of trying to rely on servo motors. I also wanted to make sure that I can control two of them with the one Arduino, and I was able to do that. So I think I've got all of the hardware that I need to go ahead with this build. So what am I trying to do? I want to have an Arduino control some stepper motors in a similar way that I was doing this manually so that I could then get the sun's light intensity for a given particular point in time. I also want to combine automating this measurement with this measurement by having it determine where the sun is. And in order to increase the accuracy, instead of using a single photoresistor, I thought I was going to use 4. So I started to do a design, and this is going to be my first prototype. It involves basically a tube that has holes cut out on either side, and it's divided into quadrants. And the idea would be to have a photoresistor in each of these quadrants at the base right here like this. The sides have a hole cut out on them like this to maximize the amount of light that shines in on any particular one side, so that the Arduino knows where the sun is shining from either one of these four directions and have it automatically track back to the correct location. I've also noticed that when the light directly shines onto the photoresistor, that the resistance is very low. It's about 200 ohms, and I need to create a voltage divider so that the Arduino is able to get a half decent reading, and I need to increase that resistance. So what I did was I designed what I called the light attenuator cap. It's just a plug that press fits on the end of this that has a few little holes in the corners cut out to let just a little bit of light in. And this is going to be something I'm going to have to try and tweak and see if it works or not. And none of this might not even work at all, but it's worth a try. And ultimately what I'm looking to do is to put this on a 2-motor gimbal kind of arrangement, where the shaft of the first motor is vertical, so that as this motor rotates, it's able to capture the azimuth. And the second motor, the shaft of the second motor is at 90 degrees from the first. So as the second one rotates, it's able to capture the altitude. Say this is where the sun is located at sunrise on the equinox. Later in the morning, it might be over here. So in order for the Arduino to move this thing back to point back towards the sun, it would see that this one would get more light than the other three. So it would move it more like that. Now it sees that these two have about the same amount of light, but that the top two get more light than the bottom two. So now it has to move these two up. And with just a little bit more fiddling, it would end up reorienting itself something like that. And so once the Arduino has repositioned these photoresistors to get that kind of reading, it would then take this and send those to the computer through the RS-232 interface, along with the average of the intensity of all four of these. And so that way there, the computer can sit there all day long and get 50, 100, 500, 1,000, 10,000 sun position readings and photoresistor readings as well. From there, I was thinking it could be used for additional projects later on. I will leave at least one idea that I had for a later project for now, but project number 2 that I had involves the cameras that I used for tracking the sun's position and the stars' positions as well. And I have a number of projects that I have in mind for these cameras, but one of the things that I want to do before I can do anything with the images that I've taken with these cameras is to be able to correct for barrel distortion. So in short, I've got one of my 2 cameras pointing in a southerly direction and pointing down from vertically about roughly where my latitude is, so that in theory this should be where the sun is at local solar noon on the equinox. Unfortunately, the camera does not have a wide enough vertical field of view to be able to capture the sun at the summer solstice or at the winter solstice. So what I did was I rotated the camera slightly in this direction, I believe, so that it would capture the sun over here during the summer solstice and down over here during the winter solstice. And I don't have the images here of Orion, but I've got a number of nights where I was able to track Betelgeuse, one of Orion's feet, I think it's his front foot, and depending on the night, I was able to capture the 3 stars that make up Orion's belt. And I think I've also got the star up here, which is Orion's arrow, or the tip of his arrow, or something like that. So I've got at least 3 stars that I can see very clearly throughout the night as it progresses across the sky. So in order for me to be able to do some of the other projects that I have in mind regarding the camera, I need to be able to correct for barrel distortion, be able to find out how much I need to rotate the image back in this direction to make it horizontal again, and then to be able to find out where the azimuth of 180 degrees is. I think it's going to be over here somewhere. And so to do that, I'm thinking of writing a small program that allows me to cycle through a number of these images very quickly, and to just click the mouse on the image where the center of that particular object is. And then when I click on the mouse like this, it registers the coordinates and saves that for later. Once I have each of these identified, it would ultimately mark down the sun's path throughout the entire day like this. And then once I have that, the ultimate would be to have a bunch of sliders, and then as I move the slider around, it would automatically take those data points and rotate them so that I could see when it lines up horizontally. And then as I move the next slider, it will apply the barrel distortion to straighten the line out. So that's the idea I have for project number 2. Please let me know in the comments below which one interests you the most first. I do plan on working on both of these along with a few others, but that's it for the moment. Thanks for watching, and I will hopefully see you again in another video soon enough. So bye for now.